Welcome back to the deep dive. You know the drill. We take a dense stack of notes and research, and we pull out exactly what you need to know right now.
And today we are going deep, truly deep, on something that feels basic but is anything but.
We're talking about the absolute foundation of programming, how your program talks to a user, and maybe more importantly, how it listens.
Standard input and output, or just I/O. It's often the first thing people learn and maybe the first thing they forget to master.
Right. And overlooking the details here can be so frustrating. Your amazing algorithm is perfect, but the whole thing falls over because it can't read a number correctly.
It's the bottleneck, the crucial, often overlooked bottleneck.
Exactly why we're here. Our mission is a rapid, thorough deep dive into standard I/O, focusing heavily on how C++ handles it. We're going to unpack the idea of streams, get the syntax down for getting data in and out.
And most importantly, we're going to tackle the biggest bugs, the things that drive beginners crazy, input failure, and that whole tricky mess with white space.
This is your shortcut. Let's unpack this.
Okay, so if we're looking at the big picture, all interaction with the computer is just data moving around.
Right.
And in C++A, we manage that movement with a concept called a stream. It's best to think of it as a sort of pipe. A flexible pipe connecting your program's memory to the outside world.
A byte for bytes. Or a conveyor belt, maybe.
A conveyor belt is a perfect analogy. And it runs in two directions. You have the input operation. That's bytes flowing into your program, into its memory, its RAM.
From where?
Well, it could be from a file, a network, but for today, we're talking about the keyboard, what we call standard input.
And the other direction is the output, the feedback loop.
Exactly, that output operation. That's the stream flowing from RAM back out to a device. Most of the time, that's the monitor, the console. Standard output.
So the program tells you what happened, what the result is.
And that's our whole focus today, just those two. Keyboard in, console out. We'll save all the complexity of file I/O for another time.
Perfect. Let's start with output then. It feels a bit more straightforward. The goal is simple, right? Just show stuff to the user.
It's your fundamental interface. You're showing text, numbers, the results of whatever your program just did.
And to do that in C++N, you need a couple of things. First, you have to include the IOStream library.
The IOStream library, yeah.
And you'll be using the ASCII namespace. The main tool, the one everyone learns on day one, is count.
Right, cout, the console output stream.
And this is how you print anything, really. A string like hello world or the value you stored in a variable. But the syntax is the key here.
It really is, because it sets the whole pattern for these stream operations.
It does. You use the double left arrow, we call that the stream insertion operator.
You're literally inserting data into the output stream, pushing it towards the monitor.
And what's really cool is you can chain them. You can just keep adding more operators to print a variable, then some text, then another variable, all in one line.
The stream just handles it all in sequence for you. It's very clean.
So you've pushed your data out. But how do you control the layout? Like, how do you end a line?
Good question. You have two main options.
Okay.
There's the endl operator, ENDL, and there's the new line escape character, just N.
And visually, they do the same thing, right? They both move the cursor to the next line.
Visually, yes, but, and this is a classic deep dive detail, under the hood, they are not the same at all.
Okay. Tell me more.
So, from a performance perspective, N is simpler. It just shoves a new line character into the stream and moves on.
And endl?
Endl does two things. It adds the new line, yes, but it also forces a flush of the output buffer.
Whoa, hold on. Flush the output buffer. What does that actually mean, and why should I care?
So your program doesn't usually print every single character the microsecond you tell it to. It's inefficient. It gathers a bunch of output in a temporary holding area, a buffer.
Right.
When the buffer's full, or at certain other times, it sends the whole batch to the console at once. Endl forces that to happen immediately. It says, send whatever you're holding right now.
Okay, so if I'm writing some high-performance code with tons of output, N is probably faster because it's not constantly stopping to flush.
Exactly. But if you're, say, printing a critical error message or debugging, and you need to be absolutely sure it appears on screen that instant,
then you use endl to force the flush. That's a great distinction. Immediacy versus performance.
Precisely.
All right, let's flip it around. Standard input.syn. This is where I think the real complexity begins, because now you're dealing with a human.
You're dealing with a user, and you can't predict what they'll do. The goal is to read data from the keyboard.
And again, you need IOStream and the SITED namespace. But this time, it's in the double right arrow.
The stream extraction operator. You're pulling data out of the input stream.
So how do we actually, grab that data and use it?
Well, you have to have a place to put it. That's the golden rule. Input has to be extracted and immediately stored into a variable.
And that variable has to be the right type, an integer for a number, a string for text, and so on.
It has to match. This is non-negotiable.
Now, this seems straightforward, but I know this is where things get messy because of whitespace. How does the operator know where one piece of input stops and the next one starts?
It's all about the white space, spaces, tabs, and critically new lines. The extraction operator has a very specific two-step process.
Okay.
First, it skips any leading white space, just ignores it until it finds a real character. Second, once it starts reading a value, like a number, it stops the second it hits the next piece of white space.
Let's use that example from the sources.
Yeah.
So the user types 10, then a space, 11, space, 15.5, space, and A, and then hits enter.
Perfect. So if your code says sin my int, the operator skips any leading junk, reads the 10, and stops dead at that first space. It leaves the rest of the stream completely untouched.
So the 11, 15.5A is still just sitting there in the pipe.
Waiting. Then, if your next line is sin another int, it will skip the space, grab the 11, and stop at the next space. It parses based on the variable's type.
So if I try to read into an integer variable, it stops at a letter or a decimal point. But if I'm reading into a double, it accepts a decimal point but would stop at a letter.
You've got it. It's all type-driven with whitespace acting as the separator. And what's fascinating is what happens when that alignment between the type and the data breaks down.
This is the critical pitfall, right? The dreaded input failure.
Yes, the silent killer of so many programs.
So walk me through it. I'm asking for the user's age, an integer,
Yeah.
and they type 20.
That is a catastrophe for the stream. The operator looks for digits, sees a T, and it panics. It can't convert that to an integer, so sin immediately enters a fail state.
What does a fail state mean? Does the program crash?
It's almost worse. It doesn't crash. It just
Yeah.
stops listening. Once sin is in that fail state, it will refuse to extract any more data, ever. Your program will just seem to skip over all your future input prompts.
So the program's still running, but the input stream is just broken.
Broken. And the sources note that in some environments, like a Jupyter notebook, it can be so bad it just crashes the whole session. You have to restart the kernel.
Wow. That's a huge aha moment for debugging. If your program mysteriously stops taking input, it's not your logic. It's probably a failed scream from earlier.
Now let's talk about the other big problem, strings.
Right. Works for a single word because it stops at a space. But what if you want someone's full name?
Then is useless. It would just grab the first name. For that, you have to use a different tool.
The getline function.
Yes, getline. It's designed to read an entire line of text, spaces and all, until it hits a specific character, which by default is the new line character when you hit enter.
And this brings us to the absolute trickiest part of I/O. The one bug that costs more debugging hours than anything else for beginners.
The white space dilemma.
It's all about how getline and handle that new line character, that N from the enter key, differently.
Completely differently. They have opposite behaviors. Let's start with getline. What does it do with the new line?
Getline is the tidy one. It reads everything up to the new line, and then it reads the new line itself and just throws it away. It discards it, cleans up the stream.
Okay, now the operator, the messy one. What does it do when it reads a number?
It reads the number, stops at the first white space, which is the new line, and it just leaves it there. It abandons it in the input stream.
And that causes the catastrophe. So let's set up the scenario. Your program asks for an age, then it asks for a full address.
Okay, so first I write some ages. The user types 35 and hits enter. So 35 goes into my age variable. But that N from the enter key is now just sitting there in the stream.
It's a ticking time bomb because what's your very next line of code?
It's getline, sin, address to get their address.
And what's the very first thing getline sees when it looks in the stream?
Oh, it sees that leftover new line character.
And its job is to read until it finds a new line. So it finds one immediately, consumes it, and stops.
It never even waits for me to type my address. The program just zips right past the prompt, leaving me with an empty address string.
That is the skipped input bug. It looks like your program is broken, but it's just a leftover character in a buffer.
Okay, that is so frustrating. But here's where it gets really interesting, because our sources point to a very specific, almost elegant fix for this.
There is. You don't have to write some complicated code to flush the buffer. You just need the loose manipulator.
Loose for white space.
Exactly. It is the lifesaver. You use it specifically when you're mixing input with getline input.
So how does it solve the problem? What does it do?
You put it in the stream right before your getline call. So you'd write sinduous. It tells the stream. Extract and discard any and all whitespace characters you find right now.
Any of them. Spaces, tabs.
And crucially, that leftover newline character, it just scrubs the string clean until it hits the first non-white space character. It preps the stream perfectly for getline to do its job.
So the correct working pattern is always read the number with N, then use Sindubas, then call getline. Without that little lose, the whole thing breaks.
That's the nuance. That's the deep dive. You have to understand that the stream is persistent. It has a memory.
And if you don't clean it, it will come back to bite you. So let's connect this to some real code. The sources mentioned all these practical exercises. Calculating the area of a circle, body mass index.
All of which need clean numerical input. If you try to calculate a BMI and the stream enters a fail state when reading the height, your calculation logic, even if it's perfect, is completely useless.
And it's the same for those intro competitive programming problems, right? Like on Caddis.
Absolutely. A problem like solving for carrots just needs a simple integer, so is fine. But then a problem called the last problem asks for a full name, which might have spaces.
And if you don't use getline and manage the stream correctly, you fail the test case. Simple as that.
It all comes down to choosing the right tool for the job.
So let's recap. What does this all mean? We started with streams, this pipe for bytes. We mastered count and the insertion operator, noting the subtle difference between endl and n.
Then we dove into the complexity of sin and the extraction operator, learning how a type mismatch leads to that silent, devastating fail state.
And finally, we found the single most frustrating bug, the skipped input from a leftover newline, and we found the solution, the awesome manipulator to explicitly clean the stream.
And without mastering these behaviors, a simple program, like a BMI calculator, just becomes unusable. The logic is irrelevant if the I/O fails.
It really is.
Which brings up a final important question for you to think about. When you're debugging and your program is acting strange, how often do you really stop and question your assumptions about what's in the input stream? What invisible characters, like a new line, might be sitting there?
That's a great point.
Because so often it's not the complex algorithm that's wrong, it was the simple, correct handling of the stream that failed first. And that silent failure in I/O cascades into what looks like a big, complex logic bug. That one tiny assumption could be costing you hours.
Something to really mull over. Thank you for joining us on this deep dive. Go try to break sin on purpose. It's the fastest way to really learn this stuff.
Until next time.